Oh, join me. Let's solve this fractional algebraic equation given to us. We are asked to solve for x plus y and not x and y. This is an Olympiad exam math question, and we are required to find the value of x plus y in 1 divided by x plus 1 divided by y equal to 1 divided by 13. As you join me, don't forget to give this video a thumbs up, share it with friends and colleagues, and if this is your first time, subscribe to my channel for more of our maths content. Now let's solve this. Now this is a fraction. The first question you ask yourself is, how can I break down this fraction in order to clear up those fractions? Remember, we are solving such that our x must be greater than 0 and our y must be greater than 0 in order for we to get the value of x plus y. Now, if we want to get that, we are going to look at multiplying through by the value of x and y. That way we can be able to clear the whole fraction. So what do? We multiply through by xy. So if we multiply through by xy, we'll have 1 divided by x multiplying xy plus 1 divided by y multiplying xy, and then we'll have this to be equal to 1 divided by 13 multiplying xy. Whatever we do to the right hand side must equally do to the left hand side. In the next step, we're going to substitute this, or we're going to clear up this. X is going to clear up x here, and then this is going to give us y plus x times 1 is x equal to xy divided by 13. Great. So we now have one fraction only on one side. We can still clear up that, and it's as easy as multiplying all through by 13. So if we multiply all through by 13, we'll multiply this point by 13, and then we'll multiply the other point by 13. So we'll have 13 plus x, and this will be equal to xy divided by 13 multiplying what? 13. So if you have that, definitely 13 will have to clear up 13. That ends the fraction saga, and then we'll have this expression to now give us 13 times y will give us 13y plus 13x, and that will be equal to x what? Xy. So what do we do from here? It's easy. I'm going to move everything to one part, one either the left hand side or right hand side, so as to have a very easy algebraic expression. So if I move all of these, the left hand side to the right hand side, that expression will now give me xy. Subtracting 13y from both sides, I'll have 13y minus 13y. Subtracting 13x from both sides, I'll have minus 13x, and this will be equal to 0. Great. Now, what do we do from here? Now, I'm going to introduce a foreign element. And what is that foreign element? If I introduce that foreign element, I won't have changed anything. And what is that foreign element? Now recall that, I'll note that if I have 13 multiplying 13, multiply 13 multiplying 13 can still give me 169, right? It's a perfect square. So I can easily add 169 and subtract 169 to that expression. I wouldn't have changed anything. Now look at what I'll do. I'm going to have this to become xy minus 13y minus 13y minus 13x, right, plus 169 minus 169. I didn't change anything in that expression, and this is equal to 0. Now if you notice, I have not changed anything. It remained the initial expression. So what I'm going to do is I'm going to do some certain grouping in order to make my expression easier. Remember, 13 is a perfect square, so I'm going to group this xy minus 13y, right, and this is going to give me minus 13x 13x minus 16, because I've included that bracket. That will become minus, and this will be minus 169, and this will be equal to 0. So I can take this over here because it's not necessary. This is now going to give me, look at this, they have a common term. I'll bring out y, right? And this will be xy divided by y will give me x, minus 13y divided by y will give me 13, right? If I now check out this, I'll see that they have one common term, and that is 13. So if I subtract 13 from them, 13x divided by 13 will give me x, minus 169 divided by 13 will give me 13, right? And if I take this over the other end, it will give me 169. So I factored out that expression. And from this expression, you can see now I have x minus 13 and x minus 13. So I'm going to group them out. Y minus 13, which is my first mass expression, and then this common term x minus 13, right, which is common. This will be equal to 169. Good. Now from this, I can easily find the value of x and y, right? Looking at the value of x and y, I can easily factorize this. If I factorize this expression, this can easily give me three cases. 1 multiplied by 169 is going to give me 169. I can have 169 multiplying by 1, and that will still give me 169. Remember, 13 multiplying 13 will still give me 169. So that means if I equate this expression and this expression to any of these or these, I can still have my result, my value for x and y. Now let's consider these three issues, these three steps. The first step will have 1 and 16. So we're going to consider that as asterisk. Case asterisk. We will have that case asterisk. We will have a y minus 13 multiplying x minus 13, and that will be equal to 1 multiplied by 169, right? So from here, if this equates this and this equates this, we're going to have that expression to now give me y minus 13, right, equal to 1, and then we'll have x minus 13 to be equal to 169. So if we expand this, we are going to have a solution to become y. In this case, will now become 1 plus 13, right? And then our y will be equal to 14, which is a solution, right? In this case, we'll have our x to be equal to 169 plus 13. 169 plus 13, x will be equal to, this is going to give us 12, 2, and this is going to give us 8 and what, 1, which is 180, 182. So from that instance, now we can see that we are asked to look for x plus y. X plus y in this instance will be equal to 182 plus 14. This will be equal to, that will give us a solution to become 182 plus this will give us 6, this will give us 9, and this will give us what, 1. So that solution will give us 169, and that is the solution. Now let's consider the second case. In the second case, what do we have? In the second case, we'll have a case that we have 169 multiplying 1, which is definitely going to give us the same thing. We have 169, case 2, we'll have the value of our x, we'll have the value of our y minus 13, y minus 13 multiplying x minus 13, and this will be equal to 169 multiplying 1, right? So we'll have that expression to give us y minus 13 equal to 169, and then we'll have x minus 13 equal to 1. If we simplify that two cases, we're going to have y to be equal to 169 plus 13, and then we'll have our x here to be equal to 1 plus 13, right? So x here will be equal to 14, which is a solution, right? And over here, our y will be equal to 169 plus 13 is going to give us 182, right? So our x plus y is going to be equal to 14 plus 182, and that will be equal to 196. Great, and that is the second case solution. Now in the third case solution, we're going to consider 13 is both equation to be equal to what? 13. So y minus 13, that's the third case solution. We're going to have the third case solution. In the third case solution, we're going to have y minus 13 multiplying x minus 13, and this will be equal to 13 multiplying 13. So if we simplify that, we'll have y minus 13 to be equal to 13, and then we'll have x minus 13 to be equal to 13. So if we simplify that, we're going to have this to become y equal to 13 plus 13, and then we'll have x to be equal to 13 plus 13, right? So if we have that to become 13 plus 13, over here our y will be equal to 26, and then our x will be equal to 26. So if we have that solution, the value of our x plus y, x plus y will now be equal to 26 plus 26, and that will be equal to 52. So 52 is the solution to that expression given to us up there. So we have three solutions, 52, and the next two solutions is 169, 196, right? And the next solution is another what? 196. So these are the solution, the possible three solutions we can get from expanding or simplifying this fractional algebraic expression. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Thanks so much for watching, and bye bye for now.